When we have rational exponents, it's telling you how to work with radicals and different kinds of roots. So when we have a rational exponent, so rational meaning a fraction, so in your exponent you have a numerator and a denominator. Say we have a numerator of 1 in the exponent and some number in the denominator. Whatever's in the denominator is telling you kind of the level of root that you're taking. So x raised to the 1 over n power is the same thing as nth root of x. So if we have x raised to the 1/4 power, that would be a 4th root of x. So it's telling you the number that goes on the outside of the radical. If you have a numerator and denominator, so the denominator is the same, that keeps telling you the level of root that you're taking. The numerator ends up being the exponent on the base. So x raised to the m over n power is the same thing as the nth root of x raised to a power of m. So the numerator, m, tells you the exponent, and the denominator n tells you the root that you're taking. So x raised to the 2/3 power, so that denominator of 3 becomes the root, so this is a third root, and then that exponent of 2 coming from the numerator goes on the base of x. So that would be the same thing as the third root of x squared. Typically when I do these, and this might just be my brain, I usually think about the denominator first, take care of that, making the radical, and then go to the number that's in the numerator. So let's look at some examples. So if we have 64 to the 1/2 power, so denominator of 2 is a square root. So you could write a 2 outside, but it's implied if we just use the root symbol, and then 64 goes underneath. And then we just evaluate. The square root of 64 is 8. Negative 27 to the 1/3 power. So that denominator of 3 is telling me to take a third root, or cube root of, and then in parentheses we have the negative 27, so all of that goes underneath the cube root. So cube root of negative 27 is the same thing as negative 3. And let's see, 4 to the 5/2, 5 over 2 power. So I'm going to focus on the denominator first. So denominator of 2 in the exponent tells me to take a square root. Then I have my base of 4 goes underneath. And then what I need to take care of is that exponent of 5. So this is a square root of 4/5. And what we'll do is take 4 to the 5th power. So 4 to the 5th power is 1024. And the square root of 1024 is 32. Now, using calculators for support here, so if I needed help just with simplifying, so I could have done 4 to the 5th power, and that would help me get that 1024. There's the square root symbol here, and then I could see the square root of 1024 is 3/2. If you get to the end without a calculator and you just want to check that you've done it correctly, what you can do is, let's see, we start with 4 and then exponent of 5 divided by 2. And then we could just see that it simplified correctly when we did this. So you can plug in the original answer since these are just dealing with numbers here, and you can make sure you simplified correctly. All right. And then our last one here, negative 16 in parentheses raised to the 3/4 power. So focusing on that denominator, we're taking a 4th root. And then in parentheses, negative 16 raised to a power of 3. So this will be a 4th root of negative 16 cubed, which will be a negative 4096. And let's see what happens when we plug this into the calculator on Desmos. So fourth root, so there's this n with a root symbol, so we'll plug that in, and then you'll type in 4, and then plugging in here, negative 4,096, and you can see it says undefined, and that's correct. This is undefined. Or we could say no real solution, or not a real number, something along those lines. What's happening is you're taking an even root of a negative number, and we can't do that. Something you're probably comfortable with is if you're asked to take the square root of a negative number, we can't do that. It's not a real number to do that. And that's the same for any even root. Any even number for our root with a negative number is going to be not a real solution, no real solution. Looking at negative numbers with odd roots, totally fine. And it's the idea that in this case, it's -3 times -3 times -3. Well, 3 negatives will make a negative in the end, and we can get that -27 out. Whereas if we're working with an even level root, so let's say I was looking at that square root of -4, while I could have 2 times 2 would give us 4, it doesn't make it negative. And if I make them both negative, it's still positive. So there's nothing that works where I can have an even number of values multiplying to each other that can give out a negative number in the end. It'll always be positive. Okay, so that's what we do with rational numbers as our exponents.